Okay, this is Chapter 1, Lesson 3, Video 3, or Video C. And it's the last lesson that we're going to cover, the last part of this lesson that we're going to cover. And we're going to look at postulates or axioms. Two words, you need to know them both. They actually mean the same thing. A postulate or an axiom is an accepted statement of fact. It's something that we accept as true even though it can't be proven. And all of geometry is based upon 7 or 8 postulates that we have to accept them as true because there's no way to prove them, really. There's no way to prove them, so we accept them as true, and then everything else we believe we can prove using those 7 or 8 postulates as our basis, and then we can prove statements from using those, and then those new statements that we proved, we can prove more, and then we can prove more, and everything builds. But it all goes back to those 7 or 8 postulates that form the foundation of everything we know about geometry. And we're going to look at 4 postulates that we're going to use, postulates that we accept as true, and then everything else that we do throughout the year, we'll use these postulates to help us prove something, and then we can use that to prove something else, and that to prove something, and we're going to build this whole geometry course based upon, you know, a few postulates, and some of which we're going to look at right now. All right, so the first postulate we're going to look at is called, well, there's no name to it. It says through any 2 points, there's exactly 1 line. Okay? If you have 2 points in space, and they are locations in space, there's only 1 line that's going to go through them. You cannot draw more than 1 line through those 2 points. You would have to make it a curve, which is no longer a line, because by definition, a line goes on in opposite directions forever. So if you have 2 points, there's only 1 line that can go through it. So that is a postulate. It's something that we accept as true, and it's called the line, the definition of a line. Very important. Now notice how this ties into how we name a line. How many points do we use to name a line? 2. Why do we do that? Because that's the definition of a line. Through any 2 points, there's only 1 line. So how should we name it? Well, let's use the 2 points that the line goes through. So that kind of ties together. I hope you see that. So through any 2 points, you can only draw 1 line. There's exactly 1. 1 and only 1. There is no other line that can go through it. So through any 2 points, that's the definition of a line. It also comes in handy because that's the shortest distance. What's the shortest distance between 2 points? It's a line. Okay? So you can see how we're going to accept that as true and how it ties together with how we name it. Okay, that's really something I'd like to see in your summary about what's the tie-in or what's the connection between the definition of a line and how we name a line. Okay, good question. I'd like you to be able to answer that. Okay, second postulate: if 2 lines intersect, they can only intersect in 1 point. Okay, only 1 point. They cannot intersect in more than 1 point. It's impossible. So if 2 lines intersect, if they do, there's only going to be 1 point where they intersect. So here's our example here. You have line AE here and line DB. Where do they intersect? Right here, right where they intersect. That is a point, only 1 point. They can't intersect anywhere else. Again, in order to do that, they would have to curve, and as soon as they start curving, they're no longer a line. So we're going to accept this as true, that if 2 lines intersect, they can only intersect in 1 point. Okay, that's the second postulate. Okay, next postulate is if 2 planes intersect, they intersect in exactly 1 line. So 2 lines intersect in a point, 2 planes intersect in a line. Now this is very important because there's a question on a quiz and on a test that I give, and I'm very picky about it because I'm going to this definition. It says if 2 planes intersect, they intersect in a line. So therefore, my answer, if I ask where do plane RST and plane STW intersect, notice that the intersection is a line. I have to name it using a line because that's how they intersect. 2 letters and the line symbol. Planes intersect, they form a line. Therefore, if I'm asked where 2 planes intersect, my answer should be a line. 2 points with the line symbol above. 2 lines intersect in a point, so my answer should be a point, a single letter. Make sure, be very careful that you write that and understand it. And then here, the last postulate, 3 points that are not on the same line, there's only one plane that can go through them. And this really is why a three-legged table will always be stable. And actually why we use a tripod when you're trying to make something secure. Because once you get those 3 points in a plane, they cannot be moved out of the plane. If you add a fourth, I don't know if I can do that, like a chair, you can have 3 in one, but then the one's not, and that's when it rocks. And when it rocks, what happens? Well, one comes up, that one goes down. So now you have 3 points in a plane again. And if you rock it back, now these 3 points are in a plane and this one's not. So you always have to have at least 3 points. There's only one plane that can go through those 3 points. So again, this is kind of like a line. How many points to make a line? 2. How do we name a line? Using how many points? 2. There's a connection between the definition of a line and how we name a line. It's the same thing here. How do we name a plane? 3 letters. How many points are there that make up a plane? 3. So the connection again. Through 3 points, there's only one plane that can go through those 3 points. Therefore, how do we name a plane? Using those 3 points that are in the plane. Okay? So I hope you make that connection, and make sure you get that information written down. A plane, that's a definition. 3 non-collinear points gives me one plane. We'll see you in class. We'll see you in class.